So Dr. Oren Etzioni was the founding CEO of AI2 from its inception until very recently, late September. He's now an advisor and board member of AI2 and the technical director of their incubator. There's a lot of great companies coming out of AI2. And despite him being very young, he's actually officially professor emeritus at the University of Washington and has been a venture partner at Madrona for a long time, since 2000. And now, on the other side, you have Carlos, who's going to participate with us online. He's a professor of computer science at Stanford, and he does work in AI/ML, AI/ML systems, AI/ML ethics and fairness, and also AI for health. And he has really good taste for shirts and art, as you can see there in his video. So Carlos also has been very active in entrepreneurship. He founded Turi. It was a company that did some very early work in deep learning systems and putting them to actual deployment. That was acquired by Apple, where he worked for about 5 years. And now he's a professor at Stanford, inventing the next thing that's going to become the next great company there. Got lots of fancy awards. One of the favorites one that I like, the name is Computers and Thought Award, and also a Brilliant 10 by Popular Science magazine. So with that, I'll pass the token to Oren to say a few words, and then Carlos, and we're going to talk. Okay? Oren, please.
Thank you, Luis. It's very rare for me that I'm outnumbered by folks from Brazil, but it's a real pleasure. And I do want to start by noting that Luis omitted a key part of Carlos's credentials. He didn't mention that Carlos is the best-looking Brazilian professor at Stanford Computer Science, specializing in these topics. And this is but from his own informal biography. Okay, and I'm really proud to have had these enduring relationships with Madrona for more than 20 years, the Allen School for more than 20 years, AI2 from inception, and now the AI2 incubator. What I want to do today is provide a bit of context and history. So we're going to have a conversation that's going to be more in-depth and a bit more technical than some of the things we've seen so far about generative models. But I wanted to help put this in context. You can take the professor out of the university, but you can't take the university teaching out of the professor. I apologize. There will be a quiz at the end of my talk before I go further, so we'll be handing out. So pay attention, please. Okay, the first thing is, right, a lot of terminology floating around. Peter Lee did a great job putting that in context. I'm going to use words like machine learning, big data, if you remember that term, data mining, supervised learning, classification, categorization. They're basically all the same thing. And the interesting thing about these terms is that they require labeled data. I used to say the dirty little secret of big data is that it requires labeled data. So what does that mean? That means if we have a sentence, if we have an image, if we have a genome sequence, we need to associate with it a label that says, okay, this is an image of a cancerous tumor. This is a benign tumor. This is a normal lung. This sentence is positive. This sentence is negative, et cetera, et cetera, et cetera. Requires labeled data. And the thing that we find ourselves in with the tremendous, with the web, with sensors from space, in every arena is that we're drowning in data, but turns out that we're short on labeled data, right? And that actually has always been a major impediment to scaling up machine learning. At Faircast, the company that I founded more than 20 years ago, and Madrona and Matt McElwain backed, and we ended up selling to Microsoft, actually had, interestingly, 1 trillion labeled data points back in the day, around 2008. And the question is, how do you get 1 trillion labeled data points, right? You can't get that from Amazon Mechanical Turk. If you just do the math, it doesn't work out. It turns out you have to figure out some kind of self-supervised scheme. You have to figure out how to automatically label the data. And again, Alex from Snorkel AI alluded to that as well. It's a key problem. So this is the first point, right? These generative models did not, magically appear all of a sudden, right? We're all talking about them. One of my favorite lines is that our overnight success has been 30 years in the making. What that means is that we started with machine learning, supervised learning was all the thing. We went to self-supervised learning, where the data is automatically labeled. That and of course the hardware trends, led to massive scale-up. And that in turn enabled pre-training, right? The idea that we're going to start with a massive foundation model, whatever you call it, a massive model that's going to allow us to do some pretty amazing things. So here's what the world looks like today with generative or foundation models. You start with input of billions of data points, maybe billions of sentences from the internet or a tremendous amount of images, the lines of code from GitHub, et cetera. And then we output a model that generates high quality, all kinds of good stuff. That's the pre-training phase. Now, at runtime, what happens? You either fine-tune the model. Let's say you want to focus on the legal domain the way Lexion does, or on the medical domain the way Peter and Nuance did. You do some fine-tuning, but then you prompt it, as it's called. You give it a textual input or description, and what comes out is a document, an image, a software, what have you. The key point is that we used to categorize. We used to say, this is a spam message, this isn't. The price is going up, the price is going down. Very recently you read about, okay, a radiologist software can say, this is a cancerous tumor, this isn't. But now we're automatically generating, we're automatically synthesizing objects, and it's a tremendous boon to all kinds of industries. So I just want to put all that in context. And here's, there's tons of these flowing on the internet. Here's a picture from Midjourney, or a set of pictures. I should also point out that open source is a big part of this. So it used to be that only a small set of people could do this. That's rapidly changing, right? So very soon, it's getting democratized, as I say. Very soon, everybody's going to be able to do this from their phone. Here's, again, just another example, okay, thanks to John Carpenter of Madrona, this works. Here's a fashion show, and what's amazing about this isn't just that this is automatically generated. What's amazing about this is the people who did it are just some creative people, right? They're not from big tech. They didn't require, they just use open source that's available to do this kind of thing. And so the creative world is being upended in some pretty amazing ways. The next comment I want to highlight is that, at least at small scale, the budget for this was minimal. The cost of these things is an issue. And of course, Luis is from OctoML, and they know all about how to drive that cost down by optimizing the hardware, optimizing the cloud you use, using various compilation techniques. So cost is an issue here, although that's going down rapidly. Access, as I mentioned, is infinite, right? Very soon, if not already, anybody can do this. Another huge thing is the diversity of tasks, okay? So it used to be that if I had Farecast and I wanted to predict airfares, I had to develop a model for that. And if I had a medical model, that's a completely different stack, completely different model. Now, as you've heard a few times, with foundation models, I build a single model and then I may fine-tune it, but a lot of the work is done ahead of time and done once. The last point I want to make is about the issue of reliability here. So a huge challenge of these models is that they hallucinate, they lie, they generate, so they invent things. An example might be people said, wow, now emails to customer service, right? We don't have to have a team do that laboriously. We'll just have GPT-3 generate those. Well, it turns out you can't actually do that in practice, because GPT-3 might invent things to say. Actually, they could be offensive in certain circumstances, or they could just be downright wrong, like, oh, we're having a free giveaway next Tuesday. Everything is free, everything must go, right? So there has to be a human in the loop. One of the big forks in the road for this, and we start talking about the future, is, are we going to have full automation, or are we going to have human in the loop? My belief is very much that we're going to have human in the loop, but this is not an obstacle to the technology. My favorite analogy for this, and maybe this dates me, but think about web search engines, particularly in their infancy and over time. So web search engines never got the answer right first time, right? You do a query, the results were often wrong, but A, we learned to make better queries, and B, we learned and they learned to make the search engines faster so that the results came back with stunning speed. And that combination means that I can query, I can get the results back, I don't like it, I change the query, and pretty soon I get what I want. Prompting of these models, I don't think is going to be something for prompting engineers and achieving total reliability. I think it's just going to be just like querying a search engine, except you're querying a generative engine. You query quickly, you get some results, you don't like them, you query again with a slightly different prompt. But now here's the killer. Over time, and particularly Google was great at this, they crowdsourced. They learned what people clicked on, what they liked, what queries they made second time around. They used the billions of queries to make the search engine much, much better. And the same thing is going to happen here. And it's already happening, right? As people query these engines and requery them and produce things, the engines are going to get better at doing what we want. So very optimistic about what's going to happen, but it is going to be this kind of human in the loop fashion. And then not to be kind of overly Pollyanna, there are these 4 challenges, though, that still remain. One is cost, which I'll let Luis and his company address. The second one is control, which I talked about. You do, despite the fact that it's human in the loop, you do worry about what these things output. The third one is specialization. So if you are in a technical domain, whether it's science, biological data, legal data, you do need to work to fine-tune the model. It'll work out of the box, just not nearly as well as it could. And then the last one, and we actually have a company at the i2 incubator that's working on this very heavily, is personalization. So let's say it's producing copy on my behalf, whether it's a memo or an email or what have you. You can't rely on a single model to do that, because the way I write is very different than the way Carlos writes or the way Luis writes or somebody else. So we actually need to have a very large collection of models if we're going to personalize this kind of writing. And we see that coming down the pike as well. So I'll stop here so that my very good-looking colleague gets a chance to give his remarks, and hopefully we'll have a good discussion. Thank you.
All right, thank you, Oren. Okay. We'll watch Carlos here. Okay.
Hello, folks. Thank you so much for having me here, and I'm sorry I can't be there in person. I'd love to meet you all and spend more time together. Oren did a great job at setting up the stage, and I've been thinking a lot about how foundation models or large language models are changing how we develop intelligent applications. Life has changed a lot in the last 15 years. If you think back to 2008, for example, machine learning was really simple. You started with some data, you did some machine learning math, and that led to profit, which at the time for me meant showing that my curve was better than your curve with some benchmark data set, and then writing a paper at a top conference about it. Life was simple, and we thought about data, the structure of a model, and how we evaluate it. But in the mindset of 2008, the model structure, what the machine learning math was about, was the most important thing. You thought a little bit about the data, you almost didn't think about how we evaluate these things. And then the big data revolution came up. And folks like Oren and Dan Weld and others had great observations saying that simple models with lots of labeled data would lead to good predictions. And this was typically in a fully supervised setting, as Oren set up. And now we're totally changing with large language models and foundation models how we think about developing applications, going beyond this idea of big data. And so today I'll talk about 3 trends that I see in the space. The first one is that big data is not the priority anymore, in my opinion. You can solve complex problems with little data. So the pipeline of 2022 looks really different. Use lots of big data, noisy data to build these language models, and then focus on prompting, on fine-tuning to solve new tasks, which enable the development of new intelligent applications for new verticals. So this is task-specific, highly curated, small data sets for fine-tuning or prompting that lead to a vertical solution that you really care about. So in the mindset right now, the quality of this prompting and fine-tuning are going to be really important. I would say that the model structure, typically only big companies or organizations with lots of resources for compute and people are going to be able to explore large-scale choices of model structures, what we focused on in 2008. Now, most of us are going to focus on how to make these vertical solutions practical by finding good quality data for it. And great companies are going to be built through this vertical specific prompting and fine tuning. And data quality is key because these models can be great, but it's not enough. They can fall off the cliff rapidly. So focusing on the data and focusing on your task can be insufficient to develop the applications you care about. So let me share a couple examples of what GPT-3 can do. So for example, you can tell it to write a review based on some prompts like food quality was poor and so on. And if you say the staff was Caucasian versus the staff was Mexican, you see very little, very starking differences. So for example, on the left, it says the only upside was that the staff was mostly Caucasian, which is disturbing, while on the right side, the Mexican staff did not make us feel welcome. So if you're building an intelligent application and you're thinking about how these models work, you have to think beyond just the data you're giving it to issues like Oren pointed out, where they can lead us to not reflect the values we're hoping to show to the world. Here's another quick example. If you ask GPT-3 to complete a story with a white king, it says the king was handsome and the princess fell in love with him, while with the black king, she was shocked that it was a black man. And I worry about this a lot. I worry about how much we're deferring to this AI and what impact will have on our societal values going forward. So beyond the quality of the data that you generate and this little segments they use to prompt or fine tune, I think evaluation and how we curate these data sets and how we create these models is going to be the most important focus going forward. So a second trend is the shift from supervised learning, so predicting, for example, the probability you'll click an ad, to generation. 2014, for example, generative models were coming up to be pretty cool. If you squint right, you'll see that second picture looks like a frog. But today, generative models are amazing. You can generate ad text, you can generate essays, you can win art competitions with generated images. And this is quite accessible. If you haven't tried Midjourney, I highly recommend it. It's really pretty cool. I tried it, and here are some examples. The first two were the ones that came before and after mine on the stream, and the one on the right is what I put. I love riding bicycles, so I put a person riding a bike fast down a hill, and this is what I got. It looks like the person's riding uphill. I don't know exactly how to change it to make it go downhill, but it's an amazing image. So generation is opening up huge opportunities of new ways AI can be applied in the world, what intelligent applications might be, beyond what we usually thought about was small conveniences of being able to predict something better. And of course, now we're re-democratizing AI. We're thinking about it new ways. The first phase of democratization of AI for me was pre-trained APIs. Let's say an optical character recognition OCR system can give some image and give me text back. Then we try to simplify training APIs. So that's what Turi was about. Make it easier for anybody to train models with the data they had, mostly in supervised settings. Today, we've gone beyond that, and we need to scale to deployments and optimization and deal with the real world complexities of building models in practice. And this is what AutoML is focusing on. And this is an incredible trend. But I'm in awe of how large language models, foundation models, have enabled others beyond developers to do amazing things with AI. The thing that I like the most about Midjourney, if you haven't tried, is the fact that you create a social experience of building prompts together, learning from other people's prompts, and jointly creating a Viking version of Bill Clinton, as you see on the bottom set here. And I wonder where this is going to take us. You might remember the scene from Star Trek 4 where Scotty is trying to talk to the mouse. And this is not Siri. This is not him giving commands to the computer, set timer for 5 minutes. This is about a conversational experience of programming the computer, where we can say more of this and less of that. And large language models give us the opportunity to create new experiences for programming, for bringing AI applications to a wide range of people that never thought they could program an AI. So with solving more complex problems with less data, to new tasks in generation, to now many more people being programmers, I think we have an amazing opportunity to do incredible things in the world, in the space, if we're thoughtful about the broader impacts of the AI technologies that we build and the places where it doesn't reflect the values that we want to bring to the world. And with that, thank you so much for having me. And I'm excited for this discussion.
All right. Okay, so well, thank you, Oren and Carlos. So I will start with a question, and I'll try to find enough time for the audience to ask questions, so start thinking about questions there too. You both mentioned foundational models as platforms and building businesses around it. So could you elaborate more on how do you see that playing out? For example, some folks argue that human knowledge should be universally accessible. Everyone should own it, so nobody should own a large model that folks build specialized models on top of. Should it be open source? Should be the role of governments to invest in it? So how do you think about foundational models as platforms from a business perspective? Carlos, you want to start? Since you're remote, you have priority.
No, Oren was ready to speak, so I'm going to defer. Go first.
I was actually pointing at you, but I never turned down an opportunity to speak. That's I love the framework that Carlos set up because things are moving. And so initially, right, we had OpenAI, and they very carefully controlled the access to it. And now we have a few companies that have it in-house, as Peter was alluding to, but we also have open source projects. We have startups doing this. So I think that it's very quickly going to be the case that there's a ton of these, and this will not be a particular bottleneck. So as Carlos and I both in different ways said, there's a rapid trend towards democratization. Did that answer your?
Yeah, it did. Even with the cost of training a foundational model from scratch being in the tens of millions or approaching hundreds of millions of dollars. So who pays for that, and who should own it in the end?
Well, I think that because a number of things are put out seeded, and in other words, you can already start with a vanilla one. As actually you've pointed out to me in previous conversations, the cost of inference is what drives this, right? So it's trained once, should be trained more times, but nevertheless, generally trained once, then it's run many, many times. So the cost parameter that I look at is what's the efficiency of inference, right? Because if I want to use this for 1 million customers, right, the way the search engine. So again, the analogy to web search engines is perfect. The biggest cost of Google is not crawling the web, even though that's a substantial cost, but it's done relatively rarely compared to the billions of queries per day. So on the inference side, I think there are many techniques from OctoML and distillation and other ones to drive that cost down and to have that cost be manageable. So long as the initial model isn't a trade secret, right? OpenAI or closed AI, as they're sometimes called, won't release it. Once I have the initial model and I can run with it, I think I'm in pretty good shape.
Great. Thank you. Carlos, you want to add anything?
Yeah, I don't know. A slightly contrarian view here. I worry about the fact if a model is open to the world, then I think lots of folks will be able to build intelligence applications with limited data, which is amazing. We have seen that the power of the model tends to scale with the number of parameters and with the amount of data you get to train with in the beginning. And I do have some concerns, and some folks here at Stanford have even better understanding of those concerns, that today that level of scaling is pretty limited in terms of access. And so I don't know the answer of who should pay for it. And I'm hoping that some folks are able to invent new techniques or new ways to collaborate amongst large sets of people to be able to train the models well. I think the actual descriptions of the models and the underlying code could be open sourced relatively easily, but the training process will still be pretty expensive for a while unless we find other ways of tackling that to train those base models.
I just, if I can add, what's a good panel without a little bit of friendly controversy among friends? So I'm less worried about this than Carlos, because a heuristic that I use is when a problem can be defined as an optimization problem, effectively as a computer science problem, our colleagues are just incredibly adept, and it's not even just Moore's Law. It's delving into the stack at getting it to be 10x better, and then getting it to be 10x better again. So we see that. So I agree with you. Right now, these are issues, but the trend is to get it rapidly cheaper. The training, the inference, the model size too, right? There's an interesting, are models going to get bigger, or are they going to get smaller? Will there be smaller specialized ones? The claim that I'm willing to bet your favorite drink, Carlos, is that 3 years from now, this will be easily an order of magnitude cheaper. To me, the harder problems is how do we use this in a way to maximize the value? That's an ill-formed problem that requires creativity. You can't give that problem to GPT-3, right? If you ask GPT-3, what's your best and highest use to build new startups, you're going to get garbage. But if you ask a bunch of smart entrepreneurs that question, you get what we're seeing right now, which is a tremendous flowering of all kinds of smart apps using generative AI.
And the last bit here of Oren's statement is totally uncontroversial. I think right now we're in the man knows no hands kind of stage where all these folks are so enamored in a good way with the capabilities that we're seeing all sorts of ways that are possible of what's possible in the space. I think as with other technology, we'll see some phases of consolidation and focusing where certain areas of impact will be defined, and we're going to have rapid development in those areas. But I'm just amazed with the creativity of what's possible today. With respect to the previous statement, I know you want to open some other questions, so I'm going to stop here. But with respect to the previous statement, I think it's a really good one. Like, I'll take you up on the bet, even though I think I might lose because you give me a chance to have a drink with you again. But what I'll say is I was more bearish until we saw Stable Diffusion come out. And I think that's kind of an indicator that you might be right. But even then, there was a lot of compute resources invested, and we're still not there in terms of the flexibility and quality of Stable Diffusion compared to other models. So betting on human creativity and ingenuity is always a good thing to do, and that's what your side of the bet in. So I'm hoping to lose, but I'll take you up.
Okay, all right. On that note, one more quick question, then we'll pass to the audience. So you both make the point, and I completely agree, that I'm in awe when what these models can do. I love playing with them as well. but the role of prompt engineering is actually really important right now because these models, despite being amazing, they are brittle. They can fail in catastrophic ways. So now putting your computer science professor hats here, so how do you see the fundamental possibility of actually being able to trust these models to do the right thing, to fail safe? So we can actually let them do their amazing things in a way that requires less intervention by humans to make sure it's doing the right thing. Is this a fundamental problem? Do you think it's solvable?
Yeah, oh, go ahead.
No, Carlos, please.
I've been focusing a lot of my research at Stanford on exactly this question. What is the framework for understanding, evaluating, testing, and what does that outer loop of machine learning look like in the context of the 2022 status quo, right? And I think a lot of incentives in the research community have been focused on, can I create a new task? Can I solve them? Can I tweak a model and so on? And bringing more of that software engineering mindset where we better define what our goals are and how to test and evaluate. How do we do things like failure analysis and systematic evaluations, I think is going to be a very important focus to bring this forward. So I am hoping that in addition to the rate of innovation in terms of the performance of the models or the capabilities of the model, that we also have another great set of innovations going on to build not just trust, but really to build the capabilities within the overall goals that we're trying to achieve.
What I would say is that this is an excellent research problem, and folks at AI2 and elsewhere are working on it as well. I still think it's going to be an extremely long time, maybe never, before you have GPT-3 or a GPT-3-based app, GPT-5 running your nuclear power plant. Okay, it's not that kind of technology. That's why I think that the analogy to web search engines is so profound. We can use, if we have human in the loop and if we have rapid iteration, we can use highly unreliable technology in a very empowering way. So my bet, not for when the research is done, but for the coming years, is that it'll be brittle. It'll be unreliable. But if we make it fast to interact with, it'll still generate tremendous amount of value.
That's right. Let me remind you that nature also builds highly reliable systems out of unreliable parts here. So it doesn't have to be perfect. It just has to be, at least as good as humans, right? So anyways, okay, with that, questions from the audience. So if I can see people here. Any questions? Otherwise, ask another one. Don't be shy. Yeah, right there in the back. You have microphones running there? Okay, all right. No, I can't.
Okay.
All right.
Okay, I'm just going to shout. I don't think the microphone's working, but one of the...
You see technology.
Hello. I'm going to shout. One of the things that you mentioned earlier was the foundation models, and something we heard earlier today from Alessia was about the lie behind the models. And I think one of the things that you put up there was the foundation models have this danger going off very quickly. I'd like to kind of hear what your thoughts are on how perhaps like that protection.
I see. Yeah, so I think it's an extension to the previous question. How do you avoid foundational models from falling off the cliff, right? So,
And the cliff being, say, toxicity or racism, I'm not sure. So many cliffs. Which one did you mean? How do you avoid them falling off any cliff? I have a very simple answer. Guardrails.
no. Guardrails.
I'm joking. I think it really depends on which cliff we're talking about. There's certainly a lot of work on both modifying the input, right? Analyzing the input and changing it before training. And what's even easier is monitoring and modifying the output, right? Because if you modify the input, you have to retrain, and that's a very expensive thing. If you just effectively bleep out certain comments, that's a lot easier. So this, I don't mean to say this is a solved problem. It's very much of an open problem, but it's not one that I think is going to be a huge blocker. It's just one that we need to pay attention to.
I think it's a huge blocker. I think it's a huge concern. I love Oren's framework from the previous question. We're talking about, is this technology is ready for mission critical applications like running a nuclear power plant? I always ask myself, what is ready to run a nuclear power plant? But starting from generation tasks and human augmentation tasks, which is what you're advocating and what I also advocate, I think is a great place where there is an actual safeguard with a human in the loop. But I still think that is insufficient to address some of these issues that I call it falling off the cliff. And the question is, which cliffs are more important than others is what you're trying to point out earlier. And some of this is going to be application specific. But the reality, though, is that thinking that addressing the gap between AIs and our values is just some salt that we can sprinkle on top of the end, like some post-processing. I think it's a bit of a limited perspective. If I'm trying to be a little, how can I say this, panelist about it. I think we need to be thinking about these issues from the very beginning of the development of AI systems, and not after the fact. And I think there are many places where we can inject our preferences or values into it. There is in the training process, there is in all the choices that we make along the way, and of course, as post-processing, like you suggested. And I think a focus on that from the beginning is going to be really important as we move forward in the AI space.
Great. Thank you, Carlos. One more question, perhaps not about guardrails, huh?
Can you hear me? Yeah. Okay, so thanks first for the very insightful discussion. So speaking of scale and everything that's happening and the trend, so a couple of years back, we thought that scaling the models was the way to go. So ever increasing models with more and more billions of parameters. But then there was this paper by DeepMind, the Chinchilla paper, that kind of showed that scaling data is sometimes much more important than scaling the model, even though scaling the model parameters also gives you a payback. That payback is small compared to scaling the training data set. So speaking of trends and predictions for the future and guesswork, what do you think is going to happen in the future? Are we running out of training data? And what's going to happen when most of the data that we can collect from the internet is actually generated by these models?
How do we avoid the circular dependence? Yeah. Do you want to start, Oren?
Sure. I guess I would say it's very much early days, and so it's not like these models are getting smaller. And the Chinchilla model, or I don't know, GPT-4, which is starting to make the rounds, may not be bigger, certainly not an order of magnitude bigger, the way GPT-3 was relative to GPT-2. But the jury is still out on what's the right number of parameters. There are many dimensions to this. However many parameters you do, how much hyperparameter tuning did you do, et cetera, et cetera. And yes, how much data. But it's not just the number of data points, right? Data that can be redundant and repetitive. I guess I would say that there's a highly technical area of optimizing the training process along all those dimensions. And to me, the thing that's guaranteed is it's going to keep getting better. I thought initially we were reaching a point of diminishing returns. Now it seems like nothing could be further from the truth. At least for the near term, these models are going to keep getting better. not necessarily more reliable, but just higher fluency, maybe less hallucinations, longer objects. You've already seen, right, the images, et cetera, et cetera. So they're getting better, and I think the jury is out on those technical details. And definitely there's going to be synthetic data, as you were alluding to, right? So these models generating. You can imagine the models also training each other, right? The way in AlphaGo, right, the model was playing against itself. Imagine a chatbot, right, built on top of this that's conversing with itself at tremendous bandwidth.
Yeah, I think that I'll latch onto a different part of the question here. I think Oren, Danweld, and others could argue again that even for the current model structures, that having more data would be a helpful thing to do. I think we're going to revisit that cycle, especially when it comes to training the foundation models themselves. And I was a little struck by your comment that we're going to run out of data. I think there's still a lot of world knowledge out there that we haven't made enough of a dent into bringing into those systems. So if I can imagine, all the books that my kid is reading right now and all that they're learning about the world through those, I don't think our models have yet been able to comprehend them in a way that all that data has been extracted and the knowledge has been synthesized. So I think there's lots of opportunity to bring new data and use the data better than we have been able to do so far. Oren probably has thoughts on that too.
I just want to add actually another point, which actually I've learned from Carlos and others. We tend to think, right, because these are we showed you these cool things with images and with text and these comments that these models generate, but the use of these models on structured data, like Copilot, which was showed, so on software and potentially other sources of structured data, and particularly in biology, this could be massive. So whatever is going to happen with textual data, there's a whole world of this where you train it on biological data and magical things happen.
Yeah, just on that point, I would say as long as there are living systems on Earth, there'll be more data, not worry about it. So if there's no more data, then I'll worry about life on Earth, so. Okay, so let's see. Let's one more question from the audience and then we'll conclude. So I saw one hand there in the back. So yeah, please. Okay,
Sorry, can you summarize the question because that didn't come through?
Tell me if I got this right. So the question was, how do you think about IP issues, separating my data from the data that's actually included in building a foundational model, and how do you think about that in the context of what these models can do? Is that right?
Yeah, and especially people that want to opt out of having their data as part of those large models, and other people monetizing them without them getting paid.
So I agree with you. This is a huge issue. The way it was in the past, as I understand, I'm not an attorney, or definitely not an IP attorney, is that if you put stuff out there and it was used to train a machine learning model, that was covered actually under fair use. That was okay to do. But now, as you said, the problem is different. I'm an artist. I put my art out there, and now it's learned a model, and part of that model is producing art in my style that I didn't produce, right? So now instead of coming to me and licensing my picture or what have you, somebody's going to type a prompt into an engine, and it'll put something out in the amazing artistic style of Oren Etzioni, and I'm out of, I wasn't making that much money before, but now I'm broke. That is a huge problem. So I think that's a legal problem, and I anticipate that the courts will have to work through that. But you hit the nail on the head. There's a real issue here.
Great. Okay. With that, let's thank the panelists, Oren and Carlos. Thank you.
Thank you.
All right. Thank you, Oren. I was asked to remind you that now there's 3 breakout sessions. Thank you.